Alright, so yesterday we talked about tangent and cotangent, and we used undefined to draw in the vertical asymptotes, and today's going to be really similar to that. So if we just start off with cosine, then cosine is this graph, starts at the 1, then it goes to the 0, -1, oops, I skipped one, 0, and +1. And then if you go the other direction, it's going to be 0, -1, back to 0, and +1. So this is our cosine graph. So if I connect these dots, this is our cosine graph. So at -360, we're at 1, because we're right here. At -270, we're at 0. -180, we're at -1. 0, 1, 0, -1, 0, and 1. And then secant, because secant is the reciprocal of cosine, so that's 1 over cosine. Then if I just take this number and flip it, so 1 over 1 is still 1. 0 over 1 is 1 over 0, which is undefined. This is still -1. This will be undefined. 1, undefined again, -1, undefined again, and 1. So one of the things we talked about yesterday is how you graph an undefined is with a vertical asymptote. So all the zeros of cosine are going to give us a vertical asymptote. So I can go ahead and graph in those. This will be a vertical asymptote. I'm going to make that more on the line. This will be a vertical asymptote, this will be a vertical asymptote, and this will be a vertical asymptote. And because these are reciprocals, if you notice, let's just take this middle point. For cosine, it gets closer and closer to 0. Well, the opposite of getting closer and closer to 0 is going up, away from 0, towards positive infinity. Remember that you're not allowed to cross vertical asymptotes. So when we go towards positive infinity, we're going to kind of shoot up towards positive infinity really, really fast. So what ends up making, or what the shape ends up doing, is it makes up this kind of U shape. This U shape. And so now for here, we'll just kind of do the dot and do this half of a U, and we'll do the other half on this side. Or if you wanted to, you could do this half. You just probably want to label this as 450 and do another vertical asymptote there. So this time, our period, a period is where it begins to repeat itself. So this upward arrow doesn't get repeated until all the way over here. So the period is 360 here, which is going to be the same as cosine's period. And that's how this is always going to look. Alright, so cosecant is the exact same, but now with sine. So if we take our typical sine graph, so that's at the 0, this is our sine graph. And now, where the zeros are, so here, 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 and here, those are going to be our vertical asymptotes. Man, I keep missing. So at -360, -180, at 0, +180, +360. So our U's are still, it's going to touch that same point. Like, these points are still going to get used, but those are now part of the U shape. So you use that as your U shape. So this one's going to be the highest point. This one right here will be the low point of this U. The high point. There we go. We're actually going to save domain and range this question until another day, so we can go ahead and skip that question. So we'll skip that on the homeworks tonight too. So basically, all that we have to do is graph sine and cosine, and then the asymptotes are always going to be where sine or cosine crosses the sinusoidal axis, because that's the 0. Because remember, when you vertically shift it, you take that 0 point and you move it up or down with a whole bunch of other transformations. But when you move it up or down, you take that 0 and you shift it up or down. So because these points, the sinusoidal points, these points represent zeros, and the zeros make 1 over 0 for secant, because 1 over cosine, 1 over 0 is undefined. Alright, so let's just take one and graph it. -5 plus 12 cosecant pi over 6 x plus 7. So cosecant is the reciprocal of sine. So we're actually going to graph sine. So my vertical shift is down 5. I move horizontally left 7. I will not reflect, so I'll start for sine with that S shape with an amplitude of 12. My period is usually 2 pi. I'm going to divide it by pi over 6. So if you do that division, you get 12, and divide that by 4, you get 3. So if I move left 7 and down 5, I need to be at -7. I'm going to add 3, I get to -4. Add 3, I get to -1, 2, and 5. This is the first cycle. 8, 11, 14, 17. This is my second cycle. If we go down 5, this is my sinusoidal axis, which is really one of the most important parts. Let's move, amplitude is 12, so down to negative, this is -5, so -17 and +7. Now I'm ready for which function? Sine. My sine, because that's the reciprocal. So I'm going to do sine here. So when I do sine, sine starts in the middle, and then it goes up, middle, down, middle, up, middle, down, middle. A lot of people go ahead and connect this, and if you connect it, that's fine. Just make it really obvious somehow that this is not your actual answer, because what your actual answer is going to be is, now we say, well, what I want to do is everywhere that it crosses the sinusoidal axis, that actually represents a 0. So when I do 1 over 0, that's going to make a vertical asymptote. So vertical asymptotes are here at the -7. Here at the -1, at the +5, the 11, and at the 17. And so now those vertical asymptotes kind of give me the boundaries of the U shape I'm going to make. And so that U shape is your final answer. So that first U shape is going to be up here at the top, and I'm going to do a U. So this is our final answer. Do a U. And there we go. Alright, let's go on to another example. I want to skip down, and do the third example. And in that third example, you're going to see y equals 3 equals. That's just a typo. That should say 3 minus. So let's go ahead and just change that to minus really quickly. Okay, so this is a secant example, and secant is cosine's reciprocal. So I'm going to graph cosine. My vertical shift is going to be up 3. My horizontal is right, pi over 2. This does reflect. So cosine that normally is up is going to actually start down this time. My amplitude is 5, and my period is going to be 2 pi over 3 over 2. So I'm going to reciprocal that 2 over 3, 2 over 3, and I get 4 pi over 3. So that's my period. Now I want to take that period and divide it by 4 to get the critical points. So 4 over 1. When you reciprocal that, you're going to end up with just, so the 4 for 4 cancels, so you end up with pi over 3. Okay, hopefully your work's a little bit neater than mine. Alright, I'm going to move right and up. So if I move right, pi over 2. And 1, 2, 3, 4. 1, 2, 3, 4. Okay, and for each critical point, I'm going to move pi over 3. So what I'm trying to do right now is I'm going to try to add pi over 2 to pi over 3. These are both fractions, and with fractions we always need a common denominator. So if I'm looking at a denominator of 2 and 3, I'm definitely going to have to change that. And 2 and 3, the first thing they can both become is a 6. So if I do this 3 over 3 and this 2 over 2, then we're actually going to end up thinking about, we're actually doing 3 pi over 6 and 2 pi over 6. So let's just go ahead and change this. There's nothing wrong with just changing it because it makes it a lot easier for us. So rather than using pi over 3, I'm going to use 2 pi over 6. And same thing, I'm going to go ahead and change it here. Right pi over 2, let's just go ahead and say, let's go right 3 pi over 6. So 3 pi over 6. So when I add 2 pi over 6, I get to 5 pi over 6, 7 pi over 6, 9 pi over 6, and 11 pi over 6. That's the first. Keep going, 13 pi over 6, 15 pi over 6, 17 pi over 6, and 19 pi over 6. Okay, I needed to move up 3. And from that up 3, I'm going to go down 5 to negative 2 and up 5 to 8. Then I'm going to use a reflected cosine, which tells me I'm actually going to start at the bottom. So down here, I'm going to start right here. And that's on the 3 pi over 6. Then I'm going to go to the middle, top, middle, bottom, middle, top, middle, bottom. So if I connect these, this is my cosine graph, but that's not actually the question. So the question is about secant. So the point of this is to say, well, here's a 0 for secant, therefore, or for cosine, I'm sorry, so this is going to be a vertical asymptote. Here's a 0 for cosine. If that's in the denominator, this is going to be a vertical asymptote. Right here is a 0, so that's going to be a vertical asymptote, and this is going to be a vertical asymptote. So let's make those vertical asymptotes. So here's my first vertical asymptote. 9 pi over 6 is my second vertical asymptote, then 13, then 17. Okay, and now I make the u's in between all those vertical asymptotes. So here's one u. Here's a second u. Here's a third u. And we really need to have 4 u's, and so since this one anytime you do cosine, because it starts at the bottom, you can either do that you have like this half of a u and this is the other half, or you can just go ahead and finish out one of these, but if you finish it out, you really need to label 21 pi over 6 and also put that as a vertical asymptote. So that's what I'm going to choose to do. Alright, so the reason why we had to do 4 u's is because it's actually 2 u's make up one cycle, because a cycle is where it begins to repeat itself. So this doesn't happen again until all the way over here. So that was at, so this has kind of been typed over, but this is at 5 pi over 6. It doesn't repeat itself until 13 pi over 6. So 5 to 13 is a difference of 8 pi over 6. So that is our period, which if you notice is the original period. If I come back up here, yeah, granted we said 4 pi over 3, but double top and bottom is the 8 pi over 6. So for secant and cosecant, the period is the same as the one you found up here. Remember for tangent it was actually half of that, but for secant and cosecant it is going to be the same. And that's it for today's notes.